Hi folks, we're going to take a look at page 369, number 3. So here we've got the question. It says an airplane has an airspeed of 300 kilometers per hour heading west, and it encounters a wind blowing 50 kilometers an hour blowing south. And what is the resultant ground velocity of the plane? Okay, so again, notice how they use the word resultant when referring to the ground velocity, because that's what there we go, just clear that up. That's what the ground velocity means. Okay, so the plane has a particular velocity which it's traveling at. It might encounter a wind, and the ground velocity represents the direction it's actually moving in. Okay, and we find that by adding the two vectors. That's why we refer to the resultant ground velocity. Okay, so let's take a look at what we have. We have 300 kilometers due west. Okay, so draw a little picture, and this one here is reasonably easy because we have these vectors at a 90-degree angle, because the other one is blowing south at 50 kilometers an hour. Okay, and so west and south obviously are perpendicular to each other. Okay, so I'm just adding them tip to tail, and so here my resultant, my ground velocity, okay, is just the hypotenuse for this right angled triangle. Okay, at least the magnitude is. Okay, and here, since we already have the west direction, this angle would be a good angle to use to describe the direction. Okay, so here I'm not even going to use trigonometry to find VG, because I just can use Pythagoras here. So the magnitude of the ground velocity is just the square root of 300 squared plus 50 squared. Okay, so let's calculate that here. Square root 300 squared plus 50 squared. Okay, and that gives us 304.14. Okay, so 304.14, so there's our magnitude, and in order to find the angle, I'm just going to use tangent here, and I'll use the ones for which I'll use tangent because I want to use the ones that have exact values to them. Okay, so we have tan of theta is equal to 50 over 300, and so theta is just the inverse tan of 50 over 300, and let's calculate that here. Inverse tan of 50 divided by 300. Okay, and we have 9.46. Okay, and so now we want to give the actual, let me look at the question. It says, what is the resultant ground velocity? So that means I am looking for the vector. So the ground velocity, which is this vector here, is 304.14 kilometers per hour. Okay, and then here we have west 9.46 degrees south. So west 9.46 degrees south. Okay, and again, what this represents is how the plane is actually moving when you take into account the velocity it's traveling at and the effect of the wind. Okay, that's it for this one.